All right, picking off with number 7. Number 7, if I notice that I have a GCF of -3 in the denominator, this would make my problem a lot easier by taking out that -3. So let's do that. And I want to cancel out the 3's here. So I get a 1 on the top. There's a negative on the outside here. 1 plus square root of 3. And we may run into negatives in the denominators a few times. Every time I do, I'm just going to push that negative into the numerator by multiplying each term by -1. So this here will become a -1 over 1 plus the square root of 3. Okay. Now let's go ahead and maybe pick a different color. Continue that as if this is what I started with. Going to multiply this by the conjugate over the conjugate, which is 1 minus the square root of 3 over 1 minus the square root of 3. On the top, if I distribute that -1, it's going to become -1 plus the square root of 3. And on the bottom, going to take 1 times 1 to get 1. 1 times the negative square root of 3, which gives me negative square root of 3. Positive square root of 3 and 1. It's a positive square root of 3. And square root of 3 times the negative square root of 3, which will give me -3. And remember, whenever you take a number and multiply it by the same numbered squared, or at least in a square root, you will get just the number on the inside. If not, you can notice that I can multiply those two terms together. That's the same thing as the square root of x squared, which is x, or technically plus or minus, but not to worry about that for now here. Alright, I have a negative and positive version of those here. This is going to be -1 plus square root of 3 and 1 minus 3, which is -2. I ran into another negative, so I'm going to push that negative into the top to get 1 minus the square root of 3 all over 2, and then it just has to simplify, so I don't need to find that in a decimal answer. That's my answer there. Let's check out number 8. Alright, number 8, I don't have a GCF. Actually, I do have another GCF in my denominator. Let's do the same step. 5 over 4 times the quantity of 1 plus the square root of 5. This time nothing cancels out, but what I can do is just work with the conjugate of that 1 plus the square root of 5. Okay, so let me erase this and multiply it. 1 minus the square root of 5 over 1 minus the square root of 5. Let's see here. Okay, do I have them on the right? Maybe a little bit. Okay, so on the top, I will leave the 5 alone, just in case at the very end there's something I can cancel it out with. Alright, on the bottom, I'm going to leave the 4 alone, and then just work with these two things being FOILed together. So I'm going to get 1 minus square root of 5 plus square root of 5 minus 5. Alright, let's do a little bit of simplifying. I'm going to get 5 over 1 minus the square root of 5, 4 times whatever 1 minus 5 is, which is -4. I'm going to get 5 times 1 minus the square root of 5 over -16. Now the 5 and the -16 don't cancel, so I can go ahead and decide to distribute the 5. And the only other thing I may do here is to move that negative in the denominator into the numerator. So this will become -5 plus 5 times the square root of 5 over +16. And you could switch the order of the numerator if you'd like to. Number 9, there will be no GCF here. I have double roots in my denominator, but that's okay because I can still use the conjugate. Okay. Let's see here. Square root of 5 times the quantity of the square root of 3 plus the square root of 5. On the bottom, I'm going to get, if you've noticed the pattern, it's going to be this with this and this times that. So let me go ahead and take advantage of that. 3 minus 5. And let's see, I'm going to get square root of 15 plus the square root of 25 over negative 2, and you might have right here just written 5 because square root of 5 times square root of 5 is that, but I'll do that on the next step. Get 15 plus 5 over negative 2, and the only other thing, I'm going to get rid of the negative in the denominator. Oops, this needs to be square root of 15. The only other thing I'm going to do is move the negative into the top, so it's going to be the negative square root of 15 minus 5 over 2. That's my answer. Let's check out 10, 11, 12. Okay, 10, 11, 12 is adding and subtracting, and then actually 12 is multiplying. Right now it doesn't look like I can combine any like terms, but I could check to see if I have simplified versions that can combine. So 3 times the square root of, I suppose, I'll do this maybe a little bit down below. So this one here, I'm going to consider 3 times the square root of 12. This one I can break up into a 3 and a 4, and this into a 2 and a 2. So I have one group of 2 that can be taken out. So in all, this is a 3 times 2 times the leftover 3 inside of the root, which is 6 times the square root of 3. So this is 6 times the square root of 3. Now let's do this one down below, or this one down below as well. 3 times square root of 18. I can break this one up into a 3 times 6, and this one into a 3 and a 2. Notice that I have another group of 3's there. Okay, so I can take out 1, 3, and multiply it to the 3 that was already in the front. And I'm left over with a 2. This is 9 times the square root of 2. And let's do the 27 as well down below. So 3 and 9, and a 3 and a 3, and then these 2 can be taken out, so I get 2 times 3 times the leftover 3 in that root. This is 6 times the square root of 3. Okay. Now who would have thought that these two numbers were the same? Anyhow, I can only combine these two because those are the only ones with the common roots. The common numbers inside of the square root at least. So this is going to be 12 times the square root of 3 plus 9 times the square root of 2. Okay. Check out number 11. I have to do the same thing. Now, I already know that, well, I guess I can do it again. I know that this 18 is going to break down into I could do 2 and 9, and this a 3 and 3. So I have one group of 3. So this whole term will break up into a 6 times the square root of 2. This one right here will break up into a minus, maybe I won't do it, 2 times square root of, let's just do it. Maybe I won't put this little thing here yet. 2 and 10 and 2 and 5. Got one group of 2's here. So I will get a minus 4 times square root of 5. And I already have a simplified version of a root there. This will be then 6 times the square root of 2 minus 6 times the square root of 5. And number 12, I have to distribute these. 2 times the square root of 5 to the square root of 6 and 2. So this and this, when I multiply those two terms together, gives me 2 times the square root of 30. And then I have a 2 square root of 5 times square root of, times 2 will give me a 4. Okay, I'm going to double check that I can't simplify 30. I get 3 times 10, 2 times 5, broke it down to all the primes, but I noticed that there is no group of 2, so actually this is my simplified version.